I begin with the following example, and I want to have a quick review about what we have to learn. So the first problem is, is this. N start from 2, y can double from 1. When it's 1, it's already 0, the denominator. So first question is it convergent or divergent? And prove it correct. Okay, so you see that, how do you see whether it's convergent or divergent? I think in many cases you can use a limited comparison test. So this is an, right? So n looks very complicated. So let's just come n squared and minus 1. You see, you can drop minus 1, okay? Because this compared to n squared, it's a very small number, can be ignored. So it's going to be ignored. Then you simplify. The series sequence. So that's your Bn, okay? And then you say, oh, Bn, 1 of n squared. So the corresponding series should be convergent by the p-series test. Right? So you have to say that the limit of n goes to infinity, n over Bn, which is going to be what? This is a positive finite, okay? And two evidence you have to provide. One is the limit is going to be 1. So you can use the limit comparison test. Then this is going to be convergent. And why it's convergent, you don't need to prove that. You have to say that by the p-series test and with p equals 2 greater than 1. So it's very clear, right? You don't need to repeat the p-series test. Right? We know that. But you have to quote, yeah. Then you can say that, then this one is convergent, okay, by the limited comparison test. Okay. And this is the best way to solve the problem, limited comparison test. Okay, you cannot easily use a comparison test. You cannot use the integral test. It's very difficult. How do you prove the integral is convergent? Okay, if you replace n by x, think about that. It's not easy. Okay, so it's convergent anyway. So you cannot use the test for divergence to prove it's divergent. Right? So this is for this particular problem, limited comparison test is unique. Yeah, the only method you can use. Okay, the only method you can use. Then then let's look at the next one. So we have, I put n on the top. Right. Now n starts from 2. Okay. So is it convergent divergent? And how to prove it? To solve this problem, you can actually use two methods. Okay. And I think it's first of all, you're trying to see how does it look like this n. Okay, it is about, right? It is do the same way. Drop the terms which are dominated by n squared. So after simplifying, it's going to be n over n, which is just 1. This is your Bn. Cool. So you can still use a limited comparison test to prove it's divergent. First of all, this limit is going to be 1 because it's easy to check. Because if we just drop some terms, constant terms, the limit will be 1. So you can, that means you can apply the limited comparison test. And this is definitely is infinite, divergent, right? So therefore, it's divergent. So you can use a limit comparison test to prove its divergence. In this case, you can also use a test for divergence to prove its divergence. That's my first method, right? Second method, you just look at this limit of n. The limit of n, it's easy to see that it's going to be 1 because n over square n square minus 1, which is 1. Okay, it's obvious. So it's not going to be 0. That's enough. You don't need to compare with any other series. So that means this series n start from 2, right, is divergent by the test for divergence, sometimes called the nth term test. Use the nth term or the nth term test for divergence. Maybe you can say that. Okay, more precise. Okay. Why? Because nth term test for divergence said that if it's convergent, then the limit of the nth term is going to be 0. Now the limit of the nth term is not 0, so therefore it's divergent. Yeah, this is a standard way when you argue with some people, right? Sometimes say, oh, if what you say is true, then blah blah blah. Then you get a contradiction. Then what you say is not true. Okay, so this is a very standard argument. Just assume what you say is right, then you prove there is a dilemma. Okay. All right, so for this particular problem, there's 2 different ways to prove it's divergent. Okay, but the argument should be complete. You cannot, skip some steps. My next question is, I know this is a divergent. Okay, why it's divergent? We already proved that it's a harmonic series. We know that. Okay, this is a harmonic series, and it is divergent. Okay. And how do we prove that's divergent? There are also 2 different ways to prove. One is use the elementary method because you just look at the partial sum. And if the partial sum has lower bound, the lower bound goes to 0, goes to infinity, then it's divergent. Okay. And another method is to use an integral test to show this is divergent. But actually, this just, you can quote to the P-series test, okay, for the divergence. P equals 1. It's divergent. So we know that this is a basic fact. Now, what happens if I change the sign? Okay. Alternatively. Okay. If I change the sign alternatively, then can we show this is a divergent or convergent? The nth term test for divergence does not work here because the limit of the nth term is still 0. Yeah, this is the an, right? The limit of n is going to be 0, clear. So the test for nth term test for divergence does not work here. You cannot say it's divergent. You cannot say it's convergent. Just, nth term is convergent to 0, but the series could be divergent, could be convergent. Right? So no method you have learned so far can be applied to here. That's what I want to say. Except for the original definition. The original definition is the partial sum, right? The partial sum. Okay. The question is whether this has a limit or not. When you write down the details, you get 1 over 1 minus 1 over 2 plus 1 over 3 minus 1 over 4. And the last term depends on the sign n, where if m is even or odd, right? So I don't know. That's I just say m minus 1 to 1 over m. Okay. Can I show this is a convergent? And when m approaches infinity, okay. So you have to think about, right? But the problem is the last term you cannot determine. So what I'm going to do, I just look at the even number m first. Then I can say that based on what I got, I have an even number terms, right? The last term here is 2k minus 1 minus 2k, right? Okay. What I can tell, if I regroup them, so I do have a 2k terms here, but if I put the parentheses there, I only got how many terms? K terms, right? First of all, I only get k terms. The sum of k terms, but each of them, do you agree it's positive, right? Right? Each of them is positive. So that indicates this partial sum when m equals to k is going to be increasing when k increases, right? Because every time you add positive terms, because you have to add a pair by pair, right? Two numbers. And then if you group it in this form, every time you add two numbers, there's a difference of two numbers. Every time you add a different two numbers. And then each term is positive. So each pair is positive. The sum of each pair is positive. So this is increasing. So my conclusion is this is increasing. So in all a sequence of an increasing sequence, whether this has a finite limit or not, depends on whether it has upper bound, right? If it has upper bound, it has a limit. Yeah. So S to K, yeah. Then I'm going to regroup group them again. What I'm going to do is I did it this way. Okay. So group them in different way. So it's going to be minus 2k minus 2 minus 2k minus 1 and minus 1 over 2k. Okay. So ignore the first term, second term, last term. I just regrouped them, right? You put the parenthesis over this over this two terms, then you can make something else. Okay, that's a tricky, but this is so special, so you can do that. And then this term is positive, this term is positive, this term is positive, right? So that means you subtract the positive terms from 1 every time, right? So that means, of course, it's less than 1 over 1 minus the last term. The last term is also minus, it's less than 1. Okay, there's upper bound, which is 1, but S2K increasing. This is kind of techniques, we call it mathematics. Some kids in the high school can do that, honestly. Those kids sometimes got to the gold medal in the Olympic math competition. Okay, some kids cannot all. Yeah. Recently, one of the some kids' mother gave me his child's resume, and because I tutored his son math when he was middle school, so he got an early admission to Princeton University. So I give me the resume, let me look at it, because I forgot how many years right now. Wow, it's amazing. Why? Resume, the first line, the middle of the first line. So he got a golden medal in the World Chemistry Olympic contest. Golden medal in the United States math competition, something like that. So high school, yeah. So I think some voice was I cut off some voice. Maybe I'm supposed to record. So anyway, so this one clearly is decreasing to 0. I don't need to, yeah, for something like that, very clear on the top, nothing there, just 1. The denominator is some terms like n, it's increasing. So then you don't need to give me like a derivative, find to prove it's decreasing. I think this is obvious. Yeah, this is obviously decreasing because the numerator is constant, denominator increasing. Increasing is also obvious. So you don't need to waste time to prove it. Okay, so you just say it's obvious, decreasing to 0. Therefore, okay, this is a convergent by the alternating series test. Okay. So, but the original series, okay, but this original series without change of sign is divergent. How do you prove it's divergent? Do you still remember? Right? Every term is positive. Every term is positive, right? What's divergent? You cannot use a comparison test here directly. Okay? But if you, there are 2 ways to prove it's divergent. Okay, 2 ways. One is direct method. We did it before. Just look at the partial sum. Okay, the partial sum, right? SM. Okay, and the partial sum actually can be simplified. It's going to be square 2 minus square 1 plus square 3 minus square 2 plus square 4 minus square 3, and so on. Square of n plus 1 minus square n. Okay, so as you can see that all the terms will be cancelled out. Square 2 cancelled out. Square 3 will be cancelled out. And even square n will be cancelled out. m. So you will get is a square m plus 1 minus 1, which goes to positive infinity. Okay? Therefore, it is divergent. Okay? So this implies, in other words, this series is going to be divergent. Okay? Okay. The second method is you look at this, but you express it in this form, like what we did. Okay. Then you compare with another series. Okay. How do you do that? You ignore the constant 1. What you get is square n plus square n, right? Almost, right? So that's going to be 2 square n, which is Bn. All right. You can let the Bn to be, if you don't like the constant, yeah, you can let the Bn to be just n to the 1 over square n. That's fine, okay? Because you want to use a P series, right? So I know this time the limit is not going to be 1. The limit as n approaches infinity is going to be 1/2, okay? Yeah, it's going to be 1/2. So 1/2 is fine. It's a number between, this is a number between 0 and the positive infinity, okay? Find a positive number, right? So you can apply the limit comparison test here. And we also should know that this Bn is divergent by the p-series test. Okay, and with p equals 1/2, which is less than 1. Okay, then you conclude that is divergent by the limited comparison test. So for the same problem, you have multiple ways to solve. Okay, if I put all the examples, all the problems on final exam, maybe that's one problem. It's a unique method you have to, yeah, you can use to prove it's divergent or convergent. But many other problems have multiple ways to solve. Some are a little bit more complicated than others, like this one, right? Yeah, like this one. I have 2 different ways to do. All right, then your question is, how do I know that? I totally forgot. So many things. Well, there's no trick here, just practice. If you more exercise and the more experience you have, then you can quickly get the idea to solve the problem. Okay? I assign the homework problem only like 10 problems for each section. That's a minimum requirement. That's for the students. Okay, you have to do that because, you know, if you do much less, then you have trouble. Okay? But if you think you have a time, okay, first of all, and you think it challenges this problem, then do more exercise. Okay? When I was a student, I did that. I did all the problems, even each section. Okay, I still couldn't get 100%. The reason is, as you see that sometimes I make mistakes, a little mistake here and there. Okay, here and there. Okay, it's not easy. So just like SAT, when you take SAT, the mathematical part, right? Even you know everything, you still cannot get 100% correct. It's so easy to miss the one or the problem. Okay, but some students can do that. Just because of mental ability. Okay, some people can hold down, focus on that without making any error. Yeah, even both students are equally good. Okay, I cannot tell the difference. Okay, so it's the same here. But you have to put enough efforts. You really want to raise, you know, from 80% to 95%. Yeah, that's very difficult from 95% to 100%. Okay. Yeah. So like this problem, right? You have 2 different ways to solve the problem. Okay. Okay. So let's look at the next one. Tell me, it's convergent with that. So this is your Bn, right? I think the Bn is positive. Why? Because n plus 1 over n is greater than 1. So it implies Bn is positive. Okay? Because if you use an alternate series test, you have to, use an alternate series test. You have to prove that it's right. Now, again, this could be written also in the different form, like this. Okay. Yeah. There's many different forms to that, and sometimes it's written in the form like that. If you put a negative sign down here, okay, then you prove whether this series is convergent or not. Yeah. That's right. It's negative. Okay. Is that right? No, my computation is wrong. You see that, right? It's easy to make mistakes. Okay, I'm gonna erase this part. Did you see that? I cannot put the n minus 1 here. Okay, but this is a, yeah, you still keep the negative sign in front. Anyway, Bn is positive, okay, and the limit of Bn, okay, is going to be the limit of 1, right? Which is 0. That's a good sign. It's positive number, the limit is 0. More likely it's always decreasing. Otherwise, okay, otherwise it's not going to be 0. So first you have to check whether it's decreasing or whether its limit is 0. A sequence of positive numbers, okay, and the limit is 0. Somehow it must decrease to 0, right? But then maybe up or down somewhere in a little bit. But if the function is defined by one single formula, I think when n sufficient large, it must be decreasing. So all I have to do is just prove, just look at this function to prove this is a negative, okay, it's a derivative. So it's easy to do that because f of x is going to be natural log of x plus 1 minus natural log of x. And then you find the derivative, which is, right? And the first number is smaller than the second number, so it's always negative. Okay, so that implies f of x is decreasing on the interval from 1 to infinity. Then it implies Bn, which is f of n, right? Decreasing for n greater than 1. All right, so therefore, this series is convergent by the alternating series test. All right. And if I change a little bit, yeah, I'm not going to put a negative sign here. Just suppose, I made a mistake last time, right? I wrote natural log 1 plus 1 of n to the power n. Okay. So we want to see whether it's convergent divergent. All right. Can you tell me if this is convergent divergent? No. If you move the power down, actually this is n times natural log 1 over 1. Right? It's not negative 1 to the power n. This is divergent. The reason it's divergent is because the limit n approaches infinity, okay, is 1 plus 1 over n to the power n is going to be e. Okay, this is well known. Okay, you can do a different way, but this is you can use this, quote this fact. So the limit of this is going to be natural log of e, which is going to be 1. It's not going to be 0. So therefore, the series is divergent. Right? By what? By the nth term test for divergence. Because the nth term test only can be used for divergence, to prove divergence of the series. Right? Yeah, I have discussed all the examples when you prepare, when you do the homework. My suggestion is to look at the lecture notes, cover the solution I provide, and redo the problem first quickly. You're not going to waste time, actually. Then you look at, compare your argument with my, anything's missing. Okay, why you miss this part? It's necessary to present there or not, right? Then you start to do the homework. Maybe that save you time. Otherwise, you spend like 2 hours to finish 10 problems. Now you spend half hour to finish your lecture notes, right? Look at that. Then you maybe only another half hour you finish the rest of it. So it saves you time, maybe. So that's always my suggestion. Okay. And do the problem by yourself. I know sometimes I'm a good student, I always do math. It sounds great. Actually, it's not. Depends on how do you use the tutors. If you ask the tutors to help you to do most of the problems, and always doing like that, I don't think you're going to make it. Okay. Occasionally, just 1 or 2 problems are confusing. Then you go over there and help. Not let them to do most of the problem. You have to spend sometimes 10 minutes, 15 minutes to figure it out by yourself. Okay. Then you will memorize it for the rest of the semester. If you spend 20 minutes, finally you figured out how to do it, and you will you enjoy the happiness, honestly. Okay, I see my daughter when she spent 10, 15 minutes figured out the problem, she started to dance, So I said, do you enjoy happiness? Yes, you see. Okay,